Hi everyone, and welcome to this video on circular graphs. Okay, so when I teach this, one of the first things I like people to do is try and just come up with any coordinates and that you can on this graph, and feel free at any point to just pause this video and just have a think about what I'm saying. So if you've done that, that's great. Now you're probably given this information up here that the radius is 5, you've probably come up with 1, 2, 3, 4, for example, 0, -5. And this one will be 5, 0. And at this point you might have got pretty stuck. You may have guessed this one is 4, 3, but is that true? And you may have had an attempt at, say, some of these ones here, if you've got some prior knowledge maybe, or you've just, given a pretty decent amount of time. Now, let's have a look at that one. Could this one be 4, 3? It kind of looks like it, doesn't it? It looks pretty much smack bang in the middle. So let's draw a radius to that point. Now, there is something we know instantly about this line. We know that is 5. And what we also know is we can clearly see that that point is crossing that line. So we know that this is 4 because it goes between 0 and 4. But the question is, I'm really sorry about those lines, they're shocking, aren't they? Is that 3? Well, if we're drawing a line straight down, we definitely have a right angle triangle, and it should be screaming at you now, Pythagorean triple. It is 3, 4, 5. If this is 4 and this is 5, this has to be 3 in a right angle triangle. So when we started thinking about this, we thought, well, can we write a formula? Well, this is always going to be r. And this horizontal distance, if we call this x, and this vertical distance, we call this y. Well, what we can say, using Pythagoras' theorem, that, well, x squared plus y squared must always be equal to r squared. And that is the formula of any circular graph, just using Pythagoras. Which means we can now use that to find some much harder coordinates, because we know that one is 4, for example, so we know this vertical height is 4. We know the radius is 5 because it's a circle, it's constant. And yeah, there you have it. So you can find an infinite amount of points now, so if you really feel like it, you can pause it and do that. But I suggest you don't. Now, what I'd suggest you do now is open a piece of graph software on your computer, something like Desmos. Really easy to use. GeoGebra is another good one, but Desmos is by far easier to use, more user-friendly. Pause the video and try and make this. Now, if you've had a go, this should have really annoyed you, because you can see that this point's not quite on 4. That might not be the thing that's annoying you, is how do you get it up here? How do you move it into this first quadrant? How did you get it from here? Now, hopefully, you've been thinking about how you translate graphs, because this is just a graph and it's been translated, it's been moved. And some of the things that hopefully entered your head is if you want to move things up or down, we can use this transformation. And if we want to move things left and right, we use this transformation. Now, you probably had no problems getting it to go right, but getting it to go up may have caused a slight issue. So let's just, for argument's sake, let's say that point is 4.5. Okay. So hopefully you've realized to move this graph to the right, we can put a transformation along that x direction. So you would have had something like this. You might have had like 4.2 or something. Then plus. Now the problem is, if we look at this one to move it up, if I keep that the same, and let's let's have a look. That goes up 4 to 7. So let's say that's a radius of 3. And remember, this has to be r squared, so that would be 9. So say something like that. If you were to draw that, you will have this graph, but this point here would be on the axis. Well, let's just pop something on. If we want to add like another 4 to it. But if I add 4 to this function, what happens? Well, actually, that would become 13. Well, basically, if you add a constant value, so if I added 4 to both sides, you have plus 4 here, right? But then that's exactly the same. But the point I'm trying to make is if you just add a constant value on its own, all it's going to do is affect the radius, not actually translate it. So, how did you do it? And hopefully you realized that with the circular graph, we're going to put it inside the bracket with this y. So we're going to translate it exactly the same way as if we wanted it to go right, we had a negative, if we want it to go up, we're going to have a negative, and let's say that's 4.1 just for argument's sake. So there's an example of an equation that you could argue is this graph in front of you. So left and right, not a problem, you should be used to that. Up and down, this is slightly different, but it should make perfect sense to you, because if you have it on its own, then it's going to affect the radius, but you need it to go up or down, so we're just going to pop that in the bracket as well, and just remember the sign change that's needed. Okay, so again, use the graphing software just to check your knowledge, but give me an equation of a circle with a radius of 7. So every time I ask you a question, pause it, have a think, maybe write it down. I'm going to go for the easiest option in the world. No transformations at all. With a radius of 7, well, remember this is r squared, that's the formula of a circle. So I'm going to go for 49. Okay, that will have a radius of 7. You could have been a bit more adventurous. Something like this. So we've got a radius of 49, but we've also got a centre of 3 left and 2 up. So that's the centre point. Now, at this point I will say, it has to always be a plus if you're wondering. If it was a minus, you actually get this sort of shape. Like the circle that was, say, here, it's just now been torn and reflected, and yeah, way more fun, you know. You've got another year till you have to be able to understand those. Okay, so give me an equation of a circle with a centre of minus 3,5. The radius doesn't matter, so have a play, and then hit play again when you're ready. So, if you got it first time, great. If you didn't, then no problem. So remember, it's always a plus. So to move the centre 3 left and 5 up, I need to have a plus 3 in my transformation in the x, and I need to have a minus 5 with the y. And you can put any number you want there, so I just put 6, my favourite number. Okay, let's have a look at another one. So, you're combining both bits of knowledge again, so have a pause and hit play when you're ready. Okay, so, it's always handy to draw a little sketch. So, here's a sketch, x-axis, y-axis, minus 4, 4, and we're going to have a radius of 2. Now you can see, if this is minus 4 and this is 4, the radius isn't going to overlap any of these axes. And it's really important to always make a sketch, make sure you understand exactly what you're doing. Even if it's as bad as mine, that's absolutely fine. So to make it go left, plus 4, and to make it go up, minus 4. Remember, this is r squared, so the radius is 2, so that has to be 4. So this is always the radius squared. Okay. Now this is a nice problem. So equation that doesn't cross either axis. Actually, that's not a great problem because there's one there. So we'll just skip past that. Now pause the video, have a go at making some of these pictures. Spend some time. You know, it's really going to help. So don't skip this, but invest some time. Make these pictures. This last one here, particularly tough. But don't beat yourself up if you can't do it. Now, 2 more things we're going to talk about is if we're going to sketch the circle with this equation. So, sketch, draw your axes, x and y. The centre, well, we've got a transformation of 2 left, so my centre is going to be minus 2 in the x. We've got a transformation of 3 up, so the centre is going to be somewhere like minus 2, 3. I'm going to put that on here as minus 2, 3. Now, the radius squared is 4, so the radius is 2. Now, this is really important. Because the radius is 2, it's going to go 2 in every direction. Now, I'm going to move that point because that is shockingly bad. So if we went minus 2, let's say that's there, and we go 3 up. Okay, so that's the point minus 2, 3. You can see it's going to touch this axis. So I'm just going to change colour for this and try and draw a circle that touches. I'm using a stylus on a screen. This is pretty hard, but on a piece of paper it's definitely easier for you guys. Now, the important bit is it can't touch here, but it has to touch. It can't miss, it can't overlap. That's really important that you've done, and you can obviously sketch it on Desmos and just to see that your creation was correct. Now, what else is useful to know, and that's basically calculating the distance between 2 points. So if we think about these 2 points, here's x, here's y, here's 2, 4, and here's 5, 8. So let's pop those on, 5, 8, 2, 4. Now what they could tell you is they could tell you that these points lie on the circle. And if they tell you that, they might tell you a bit more information. They might tell you that this is a diameter, for example, and you might want to know the distance. And if it is a diameter, then you can work out the center because it'd just be the middle of both of them. So that's pretty easy. And then you've got the radius, obviously half of the diameter. So how do we work this out? So it's just Pythagoras' theorem again. So if you think about drawing this distance across here is 3. This height change is 4. So you know that's 5. It's in Pythagoras' theorem. But as a formula, you could write the distance, it could be diameter in this case, but distance is the square root of this change in x. So if I write x2 take away x1 squared, that would be the change in x, which is just 3. Sometimes it's easier just to draw a picture and look at the numbers, plus the change in the y, so y2 minus y1 all squared. So keep that in your mind, have a go at the Word document I sent you this morning, and you're well on your way for understanding circular graphs.